Guys, we are also going to evaluate this infinite series. So, so sum from 1 to infinity this rational function, right? So if you see these linear factors here, product of linear factors, your denominator is product of linear factors, and the numerator is you have a linear factor. So you can split into partial fractions very easily. So first step is to split into partial fractions, right? So these are the partial fractions. So we have to find these coefficients a and b. So you can find a and b by comparing coefficients of both sides. Let's compare coefficients of n terms. So your left hand side, so this is the coefficient here, so here 1. Now we are comparing coefficients of n. Get an equation. Let's kill this n just by subbing 0 into n, right? So 5 equals 3a plus 2b. I think you can solve these simultaneous equations. So negative, I multiply the first equation by negative 2, negative 2, negative 2, negative 2, then I add both of them, both the equation, then 3 equals a and b is equal to negative 2, right? So these are partial fraction. Then I multiply this equation by this thing, this factor here. So I'm lazy to write everything. Okay. So I show 5 times n divided by n plus 2 times n plus 3 multiplied by 2 times 2 over 3 to the power n, which is equal to so first factor is n plus 2. Here you have a 3 on denominator. So on numerator there was a 3 here. That 3 goes with one of 3's of this factor, right? Then you get something like, yeah, here you have 2 to the power n, and here you have 3 to the power n minus 1, n minus 1. And the other factor, other term, negative 2 over n plus 3 times this one, 2 to the power n over 3 to the power n. So I write these two terms together, then n plus 1 here. Notice these two terms here. If you replace n with n plus 1 here, so this makes this term, exactly this term here. So 2 to the power, this becomes 2 to the power n plus 1, and your denominator become n plus 3 times 3 to the n. So pretty simple. Then you can you n equals that thing, this thing, right, this thing. Then you can consider sum of u1 by substituting 1 into here, plugging numbers, right? So 2 over 3 minus 2 squared over 4 times 3 to the power 1, first term, second term by plugging 2 into the equation. Then here look at this, 2 squared over 4 times 3 to the power 1 minus a new term, 2 to the 3. I think you might love this problem. I think this one is a very easy problem, right? Yeah, and you substitute 5 times 3 to the power 2, like that. And the general term, let's write the general term, un. I can't see the ball. I can't see the ball. Alright, wait. Okay. 2 to the n over n plus 2 times 3 n minus 1 minus 2 to the n plus 1 divided by n plus 3 3 to the power n. You sum this up, this goes with this goes with this goes with the previous one, and you end up with having sum, finite sum r goes from 1 to n. UR is equal to 2/3 minus 2 to the power n plus 1 divided by n plus 3 and 3 to the n. Yeah, as n tends to infinity. If you want to find the sum of infinite series, all you need to do is take a limit of from the both side. This goes from 1 to infinity, this becomes 1 to infinity sum right hand side, this term becomes negligible. This term goes to 0 as n tends to infinity. The sum is 2/3. The sum of that infinite series is 2/3. So the sum of this infinite series is 2/3, right? Hope you understood this one very clearly, right? Think you can do these type of questions. I think you can complete your exam problems, right? Alright, see you in next video.